Hi students, now in this video we will discuss about the reactivity of metals, how metals react with the water. However, you need to be a little bit careful. Do not perform the experiment with the metals like sodium and the potassium with water in your lab, because the sodium and the potassium is highly reactive metal, and often when you put these metals in the water it catches fire. So all these experiments, they should be performed under the supervision of your chemistry teacher. However, you can use other metals for the experiment to determine the reactivity of the metals with the water. You can use the metals like iron, magnesium and the copper. You can use also the calcium, you can use the zinc and other metals. Now the metals, when you react with water, they form the metal oxide and the hydrogen gas. The metal oxide here then again reacts with the water and then forms metal hydroxide. And these reactions are normally exothermic. The hydrogen gas which is released here can catch the fire when we use the metal like sodium and the potassium. Not all the metals actually have the same reactivity. Some metals react with cold water because they are highly reactive. Some metals do not react with the cold water, we need hot water. Some metals do not react with the hot water, they react with the steam, which means that metals have different reactivities. So actually when we react the metal with the water, you get a metal oxide. The metal oxide here then again reacts with the water and forms metal hydroxide. Metals like sodium and the potassium, which are highly reactive, can react with the cold water. So these metals are highly reactive, that's why they can even react with the cold water. Hot water, reaction is tremendously exothermic and it's violent, right? So both metals here, they react with the cold water and form the hydroxides. Potassium reacts with the water and forms potassium hydroxide. Sodium reacts with the water and forms sodium hydroxide plus hydrogen gas, and energy is released here. The hydrogen gas which is released here catches the fire because the energy here is sufficient to do the combustion of this fuel, the hydrogen gas which is released here. So often this reaction catches the fire once you put the sodium or the potassium metal in the water, so it catches fire. So that's why you need to be a little bit careful. Metal like calcium, you can perform the experiment safely with it because the reaction is not so much exothermic. Okay, hydrogen, the heat energy that's released here is not enough that can cause the combustion of the hydrogen gas. Magnesium does not react with the cold water, we need very hot water, only then it can react and form the magnesium hydroxide plus hydrogen gas. Metals like aluminium and iron do not react with the hot water, you need steam here. Okay, we need steam, which means that the metals like aluminium and iron, they are least reactive. Okay, that's why they don't react with the hot water or the cold water, you need steam, and then it can form the aluminium oxide or the ferric oxide. Other metals like copper, silver, gold, lead do not react, which means these are very less reactive. Okay, these are the least reactive metals here. and therefore we can arrange these metals in the order of their reactivities. The top one here is the most reactive, the bottom ones, they are the least reactive. So therefore the order of reactivity will be potassium the topmost, then sodium, calcium, magnesium, aluminium, iron, and these one the least reactive metals. So that means not all the metals can react with the water and form metal hydroxides, only the reactive metals or moderately reactive metals can react with the water and form the metal hydroxide and the hydrogen gas. Hope you got the concept. Thanks for watching the video. Bye for now.